Happy day. I am Haripriya, Assistant Professor in the Department of Food Science, M.O.P. College for Women. In today's session, we will discuss about gelatinization of starch. Starch is a storage carbohydrate in plants. It is a homopolysaccharide. It contains only glucose units. It has two important components in it, amylose and amylopectin. Amylose is an unbranched chain of glucose units and around 15 to 20% of the starch component is made up of amylose. When we talk about amylopectin, it is a main component in starch and it is a branched chain polymer. 65 to 80% of the starch is made up of amylopectin, and all of us know that cooking improves the digestibility of starch by making it more soluble. Now let us discuss on the characteristics of amylose and amylopectin. Amylose is a straight chain polysaccharide, as we already discussed. It is made up of number of glucose units put together by alpha 1,4 glycosidic linkage. Amylose is soluble in water and it gives a deep blue color with iodine. And amylose increases the gel strength. We already saw that 15 to 20% of our starch is made up of amylose. For example, rice has 16% amylose, potato has 20% and wheat has 22% of amylose. You can look into the diagram over there. It is a number of glucose units put together by alpha 1,4 linkages. Two glucose units are put together by the alpha 1,4 linkage. It is a linear polymer of glucose units put together. Now next one is amylopectin. It is a highly branched polymer of our glucose and the branching occurs at the every 24 to 30th residue. Around 3000 to 6000 glucose units are put together in our amylopectin. Amylopectin is insoluble in water. Amylopectin gives a red to violet color with iodine, and high amylo content lowers the ability to form a good gel. Now when you look into the picture, you can see here the branching has happened and there is a alpha 1,6 linkage at the branch. When we look into the starches food sources, potato, rice, wheat, corn, tapioca are the common food sources of starch, and starch granules vary with the size and the appearance. For example, look into the cornstarch. It is polygonal in shape and it is around 15 micron. Look into barley, it is round, elliptical and the size is between 2 to 35 micron. The starch granules of rice are very small, it is polygonal in structure and the size is around 5 micron. And wheat is a mixture of small, round and lenticular grains and the size is around 20 to 22 micron. Now when you look into the enzymes which can hydrolyze starch, there are two important enzymes. One is alpha amylase and the debranching enzymes. This alpha amylase can act on the 1,4 linkages and break the starch into smaller component. Debranching enzymes can break the alpha 1,6 linkages. Now moving on to the concept of starch gelatinization. We all know that starch gelatinization is a process involving heat and water. Okay, it's a very crucial process in determining the texture of the food and also the nutritive property of our starch based foods. Starch is basically insoluble in water. When we heat the starch along with water, the starch granules break up. The hydrogen bond between the starch granules break up. They start taking up the water and they swell up. When we continue heating, the starch granules swells much more and at one point they burst out and some of the soluble component in the starch will leach out to the water, and here the viscosity of the paste will increase and the translucency of the mixture also will increase. So this overall phenomenon wherein the intermolecular hydrogen bonding being broken down, starch absorbing more moisture and the translucency of the mixture increasing, all this put together is called as gelatinization of starch. The temperature at which the starch granules begin to swell up and lose the birefringence, we call it as gelatinization temperature. Usually we say that when the starch loses around 98% of the birefringence, we take it as a gelatinization temperature. And usually the range is between 70 to 88 degrees centigrade. Larger starch granules will swell at a lower temperature. For example, the roots and tubers, they have a gelatinization temperature of 56 to 70 degree centigrade, and the cereal grains have a gelatinization temperature of 60 to 75 degrees centigrade. The gelatinization temperature varies with the variety of the food source and also with the storage temperature. And we use gelatinization temperature range as an identification of the starch. The structure, the composition of the starch will also determine the gelatinization temperature. The amylopectin, the number of branching the amylopectin has also will determine the gelatinization temperature. And we should remember that more the amylopectin, the starch paste will be more thicker, and more the amylose, stronger will be the gel. And if it is a high amylose content starch, then it need a higher gelatinization temperature. Now moving on to factors affecting gelatinization. Sufficient water is the first requirement for gelatinization to happen. The next one is the temperature. As already discussed, larger granules will gelatinize at a lower temperature. For example, potato starch. That's why we use potato starch in ready to make soup mix and all. Then timing. If we heat beyond the gelatinization temperature, sometimes the viscosity decreases and the granules will break apart. Stirring. Stirring is desirable at the initial stage of gelatinization, but later if we keep continuing stirring, it may break down the starch granules and the viscosity decreases. Now acid. pH below 4 will decrease the viscosity. Any acid juices like lemon juice or vinegar, we need to add it only after the completion of the gelatinization. Acidity will allow the starch to get hydrolyzed, so the viscosity will come down. Now addition of sugar. Sugar will always compete with water and it delays the gelatinization process. Fat and protein in the food also delays the gelatinization process by coating the starch granules. So fat, protein and sugar usually delays the gelatinization process. So these are the factors which affect the gelatinization. So in recap, in today's session we have talked about the components of starch. Starch is made up of amylose and amylopectin. Amylose is a linear chain of glucose put together by alpha 1,4 linkage. Amylopectin is a branched chain, the branching happening by alpha 1,6 linkages. And then we talked about the process of gelatinization, wherein when we heat starch with water, the hydrogen bonding breaks up, starch takes up more water, it swells up, the viscosity increases, the bifringence is lost, translucency increases. The temperature at which all this process happens, we call it as gelatinization temperature. And gelatinization temperature is an identification mark for every individual starch granule. Thank you.